I'm going to demonstrate how data can be obtained from a source using REST API calls. In this case, I'll be using an internet-hosted weather data service called openweathermap.org. I'll be obtaining the latest weather metrics for Mayfield Heights in Ohio every 5 minutes and recording them as stream attributes. Having obtained an API key from openweathermap.org to allow me to access their data, I've read their API documentation and determined the API call syntax that I need to use. Entuity version 20 allows user-defined REST API polars to be defined. Each polar can be used to gather data for one or more devices. In this case, I've created a ping-only device, and I'll be assigning that for this polar. The IP address that the ping-only device is pinging is irrelevant, so I've used the local loopback address. As I don't already have any REST polars defined, the first page displayed gives me high-level guidance as to how to proceed, and you'll see that the Overview tab is selected. The creation of REST polars follows a wizard-like workflow, starting at the left of the display tabs and proceeding one tab at a time till you reach the Summary tab on the right, which then allows you to save your work. This will be a mandatory step, so it shouldn't be overlooked. If one or more polars had already been defined, the first tab displayed would have been the Polars tab, which shows a list of the available polars. To begin, I'll manually advance to the Polars tab and click the Create Polar button. This displays the General tab, which allows me to name the polar. I'll call it Mayfield Heights. Note that the name must not contain spaces. I'll select a ping-only device as the context type. For the display name, I'm going to use Mayfield Heights again, but this time it can include a space. For the description, I'll use Weather for Mayfield Heights. And once again, this is allowed to contain spaces. For the visibility, off the menu, I'll choose Shortlisted, as there won't be many attributes and it would be convenient to have them immediately available for elsewhere in the user interface. I'll leave the polling period set to 5 minutes, but change the retention period to 2 weeks. You'll notice that if longer polling periods are chosen, the maximum retention period will also increase. There's one more thing I need to do before proceeding, and that's to define which device or devices this polar will appear on. So I'll just choose the ping-only device I created earlier. There's a single step already allocated by default, and I'm going to proceed to define its contents by clicking the Next button. The REST call that I'll be using only requires a single step. If I'd clicked the New Step button at this point, it would have allocated a second step, which isn't my intention. The call to the openweathermap.org API doesn't require authentication, as it uses an inbuilt API key, so I'll choose No Credentials from the Credential Mode option. I'll be asking it to perform a simple GET operation. The connection URL is the syntax I worked out earlier. When this URL is used by the polar, it will replace the embedded host name with whatever is provided in the host field. By default, this will be the name of the device on which the polar is being run. In my case, this isn't appropriate, so I'm going to enter the correct host name in the host field. By default, the port field will automatically use TCP port 80 or 443, depending on whether the URL specified HTTP or HTTPS. If some other port number should be used, it can be entered here. No special header information needs to be provided, so I'll leave the headers field unchanged. A very handy test feature is provided, which runs the provided URL exactly as entered. This means that the included hostname will be used. At runtime, this may be replaced with a different hostname according to the contents of the host field. The results of the call are displayed so you can check that the return data looks correct. In my case, here's the return JSON body, and we have lots of weather information, including down here the temperature, a feels like temperature, and various other information including pressure and humidity. Now it's time to move to the next step. You'll see that the Parameterize tab shows each part of the URL syntax separately and provides the opportunity to define how individual sections can be dynamically substituted with different contents. However, in this case, I won't be needing to make any such substitutions. The next step allows variables to be defined that allow data to be passed between steps, but as I'm only using a single step, I can ignore this facility for now. The attributes step allows one or more attributes to be defined along with the logic to populate their contents from the results of the API call. It's important to note that a single API call can return the contents of several attributes, which is different to how SNMP polling is implemented. I'll add my first attribute, which I'm going to use to return the current temperature. I'll enter the name of the attribute, and for the source path, this can be filled in automatically using the Data Explorer. This provides a tree-structured representation of the returned JSON data. In this case, the current temperature is within the main block, and I can expand that and select it. You'll also notice that it's numeric and floating point. The display name now defaults to the name in the JSON results, but I'm going to override that. I'd like to treat the data numerically rather than just as a string. And as it's in floating point format, I'll choose float 32 as I don't need a high level of numeric precision. For the display format, although there is a display format of temperature listed as an option, I'm going to just choose float as the default unit of temperature is Celsius, and I defined in the URL that imperial units should be used, so I'll be showing the temperature in Fahrenheit. I'll leave the visibility set to shortlisted to allow the temperature attribute to be selected without having to ask for further options. The graphable setting can be left to automatically assume that a floating point value can be graphed. The returned value is to be used directly rather than converted into some other meaning, so the enumerable option is left unselected, as is the searchable option, as there is no need to allow searching based on the temperature. This would be relevant if textual details were returned that might want to be searched against. I'm not going to define a range, and there's no relevance to using the returned value to name the object or set its status in this example. The last remaining change that I'll make is to define a threshold-based event. When operating in threshold mode, a threshold will need to be chosen. I'll define one now and call it high temperature. Again, spaces are not allowed. I'll use high temperature as the display name and provide a suitable description. It's always a good idea to enter meaningful descriptions as they can help others who will need to understand this custom configuration at a later date. The group name is simply a string tag that will be shown against the threshold, and I'll use weather. As the temperature is in Fahrenheit, I'll provide an F as its unit. The minimum and maximum values can be set, and I'm going to use -20 and 120 respectively. I'll leave the default value for the threshold set at 50 degrees Fahrenheit and leave it enabled by default. Here's the high temperature threshold that I just defined, and this dialog allows multiple additional thresholds to be defined that would raise different events against the same attribute. There are 4 different events that can be raised, and I'll leave it set to raise a critical event. You can see the result at the bottom of the dialog. I'll take this opportunity to add another attribute to the same polar. This will be for the humidity. Once again, from the Data Explorer, I'm going to choose the required attribute, and this one is returning a numeric integer. The value returned is going to be the relative humidity, which is represented as a percentage. First, let me choose an integer. 32-bit integer should be fine for this purpose. And for the display format, I'm going to choose percentage. None of the other values need modification, and I won't be defining an event for this attribute. At this stage, it might be tempting to assume that all of the work has been completed, but there's one very important operation left to perform. Click the Next button. That takes you to the Summary tab, and you must click Save in order to ensure that the work you've just been doing is properly saved in the database. The UI now shows the Polars tab again, and the new polar is listed below. Incidentally, if you were defining this polar on a consolidation server in a multi-server configuration, it would have automatically created the same polar on all the remote servers, and this is indicated by the green check mark in the sync column. Any subsequent changes made to its configuration on the consolidation server will also be immediately copied to all the remote servers. Let's leave the system gathering data samples for a while. We've been gathering data for a few hours now, so I'm going to go and take a look at the data samples that we have in the database. I'll navigate to the device that we have the polar attached to, but you'll find that the attributes are not available directly on this device. That's because there is a polar object containing the attributes, and that is associated to the device. To locate the object, I'm going to use the Associations dashboard. Here, you'll see that there is a Mayfield Heights association. That was the name we gave to the polar, and I can select it. You'll see that that is now coming up as a subcomponent of the monitored device. If I now choose the Attributes dashboard, you will see all of the standard attributes plus the temperature and humidity. Now, each of these that we've added has appeared twice. That's because we have both a stream graphable form of the attribute and an object form of the attribute. This has a single value. This has a stream of history. Likewise for the temperature. If I was to look at the temperature, I could show the history. These are the various temperature samples we've been taking every 5 minutes. If I were to graph that, these are the samples we took since the polar was put in place. I'm now going to create a dashboard to take advantage of these new metrics. I'll use the dashboard configuration and create a dashboard. Let's call the dashboard Weather. And I'm going to make this dashboard applicable not to a view, but to a ping-only device. I'll assign it just to the administrators group for now. And let's make it a favorite. I'll put a chart showing the temperature on the dashboard. You'll see it is applicable to that ping-only device. I'm going to add a series, and the attribute I'm going to choose isn't on the standard list. I'm going to show more and go down to where the object that is holding these attributes is listed. You'll see here it was called Mayfield Heights. So that is the polar object, and it's going to be the temperature that I'm interested in. I've selected the temperature, and let's leave that with default settings for everything else. Let's stretch it to take up the whole room, and I'm going to add another panel underneath, which will be the humidity. Once again, down to that object that I've added, the Mayfield Heights object, and here you will see the humidity listed. Again, I'm going to stretch it to take up the whole width of the screen. Save it, preview the result, and this is not an error. That's because we are not pointing at an object or a device that has a polar. Let me navigate to that device that has the polar, and you'll see the data that we've been gathering today. That looks good. I'll exit from the dashboard creation. Let's go over to take a look at the devices. Here it is right at the top of the list. I'm going to reorganize that, reorder them so that it is no longer the highest priority. I'm just going to drag it down, and we'll put it down, let's say, at that position here. Okay, that done. Let's go back to the home page. I will navigate to my ping-only device, and you'll see we've got a weather dashboard. Select the weather dashboard, and I have my weather metrics. On a different system, I built one of these polars a while ago and filled it out with extra attributes, and this is the type of effect that you can create with a custom dashboard.